Good morning. In this video, we are going to construct the decision tree for the following training dataset using decision tree algorithm. So here we are going to use algorithm named ID3. ID3 algorithm is used for solving this decision tree problem, and this is a dataset we are using for constructing the decision tree, and these are the features for the data set, and this is a target column. So the features involved in this data set are age, income, students, credit rating, and the bias computer. And bias computer is a target column. The target column consists of two class S and no, and we are going to find based on these attributes whether it belongs to class S or class no. So there are first and foremost step is to find the entropy and information gain using these formulas. The entropy is given by the formula minus summation of I is equal to 1 to n pi log 2 pi, where pi is a probability of getting that particular category. So the average entropy can be calculated using this formula, and the information gain can be calculated using this formula, that is entropy of the parent minus average entropy of the child. So for this, to construct a decision tree, first we have to calculate the overall entropy for the given data set. So the overall entropy can be calculated from this data set. There are totally 14 rows, and out of that there are 9 S and 5 no's. So 9 S and 5 no's. So the overall entropy can be calculated by 9 by 14, taking 9 by 14 of probability of getting S and 5 by 14 of probability of getting no. So here your entropy will become minus 9 by 14 log 2 9 by 14 minus 5 by 14 log 2 5 by 14, which is 0.940 bits. Here bits is the units used for measuring entropy. So 9 by 14 is the probability of getting S and 5 by 14 is the probability of getting no. So substitute the values in the entropy formula. We are getting the value is 0.94. So bits is a unit used for measuring entropy. So first step is finding the root node of your decision tree. You all know your decision tree will be consist of a root node and decision node, and then your decision node contain leaf nodes. So we are going to construct a decision tree for the given data set. So for this, the features have to be considered, and the information gain for each features have to be calculated, and the feature having highest information gain will be chosen as a root node of your decision tree. So first step is finding the root node. So here I'm taking, let me take the first category as age, and age is having three categories: less than or equal to 30, 31 to 40, and greater than 40. So if my age is less than or equal to 30, I'm having 5 rows from the given data. So I'm splitting the data set into 3 different categories based on the category of age. So for less than or equal to 30, I'm taking entropy as E1. For 31 to 40, I'm taking entropy as E2. And for greater than 40, and my entropy is A3. So there are totally 5 rows for less than or equal to 30, and 4 rows for 31 to 40, and 5 rows for greater than 40. So for less than or equal to 30, I'm having 2 S and 3 no's. So there are totally 5. And for 31 to 40, I'm having 4 S. And for greater than 40, I'm having 3 S and 2 no's. So those are mentioned here, which are used for the calculation of entropies. So the entropy for that particular category can be calculated by E1 is equal to minus 2 by 5 log 2 by 5 minus 3 by 5 log 2 3 by 5. And entropy for 31 to 40 is minus 4 by 4 log 2 4 by 4. Here in this particular category, all the rows belongs to same class. So if any of the category is having all the rows belongs to same class, then this entropy is simply becomes 0. Since log to 1, since the value of log to 1 is 0, the value entropy will become 0. So for greater than 40, the entropy I have calculated as before, and this is the average entropy you have to calculate. So the average entropy is a formula as I mentioned before. So with the entropy of the particular category, we have to multiply with the probability of the getting that particular category. So the probability of getting less than or equal to 30 is 5 by 14, and 31 to 40, probability of getting 31 to 40 is 4 by 14, and probability of getting greater than 40 is 5 by 14. So substituting the values in the average entropy, 5 by 14 into E1 plus 4 by 14 into E2 plus 5 by 14 into E3, we can get the value for average entropy, and the information gain of age can be calculated from the formula overall entropy minus average entropy of that particular category. Here the overall entropy, parent entropy is 0.94 and the average entropy is 0.694. While substituting the values, you will get the information gain for age as 0.246 bits. Hence, so we have to, like, using these same steps, we have to calculate the information gain for income. So income is having three categories: high, medium and low. So based on those three categories, I'm splitting the data set into three divisions. So if my income is high, then the class, it belongs to two class, S and no. So 2S and 2 no's, totally 4 rows. And my income is medium, I'm having totally 6 rows, and in those 6 rows there are 4S and 2 no's. So total probability of getting medium is 6 by 14, and I'll taking low as my category. I'm having 4 rows, out of which there are 3 S and 1 no. So the probability of getting low is 4 by 14. So substituting the values of using those values, you have to calculate the entropies of that particular categories, and that substituting the value of probability of getting the category and the entropy, we can find the average entropy, and then substituting the value of average entropy, we have to find the information gain of income. Before that, let me tell you how to calculate log value. So here we are going to calculate log base 2 value. So in your scientific calculator, you will have log button that will represent log base 10. So for calculating log x base 2, we have to find log x divided by log 2 using your scientific calculator. That will give you the answer of log x base 2. So let me continue the problem. So we have calculated the entropy for the incomes and income for the income categories, and we have to substitute the entropy values in the average entropy to find the average entropy. So here 4 by 14 into E1 plus 6 by 14 into E2 and plus 4 by 14 into E3. So substituting the values, you'll get an answer, and while substituting the average entropy in information gain, the information gain of income is now become 0.03. So in the same way, I have to calculate the information gain for next feature. The next feature is student. The student is having two categories, S and no. If I'm choosing S, it is the data set is split into two. So if I'm choosing S, there are 7 rows. Well, the student is S, and there are 7 rows if the student is no. So if I'm choosing S, I'm having 6 S and 1 no, and the total probability of getting student S is 7 by 14, and for no is 7 by 14. So for no, so for these two categories, we have to calculate the entropies, and the average entropy is calculated by 7 by 14 into E1, the 7 by 14 into E2, and the information gain for student can be calculated from the overall entropy minus average entropy, which is 0.152. So next one, the credit rating attribute, and it is having two categories, fair and excellent. So for fair, there is 6 yes and 2 no's, and there are total 8 rows. And for excellent, there are 3 yes and 3 no, total 6 rows. So the probability of getting fair is 8 by 14, probability of getting excellent is 6 by 14, and even and E2 are calculated based on this S and no values, and the average entropy can be calculated from the given values, and the information gain for credit rating can be calculated as 0.048 while substituting the values. So now we have got the information gain for all the 4 features, 4 attributes: age, income, student, and credit rating. Out of those, we have to choose the highest information gain as a root node. So here the highest information gain we have got highest information gain for age. Now your decision tree will be looking like this. So age, while taking age as a root node, we are having 3 choices: less than or equal to 30, 31 to 40, and greater than 40. So we are going to split our data into 3 subsets, satisfying the condition. So here, while seeing the 3 subsets, each subset is having the left side subset is having 5 values. Out of 5 values, it is having the target class. Both classes are present in the target class, S and no. And the right side subset is having the 2 classes, S and no. But in the middle class, all the rows belongs to the same class S. Hence, we can simply write the node as a leaf node, which belongs to class S. So if the age is 31 to 40, they will definitely going to buy the computer. They will simply belongs to the class S. So your decision tree will now look like this. Yes. So now you are having 2 subsets for which we have to calculate the information gain and find the decision node. Which decision node comes next? So there are 3 attributes. So we have to find the information gain for those 3 attributes. Let me take the left subset first and solve. So first we have taken the left subset, which consists of 3 attributes, and the overall entropy can be calculated from the given subset. We have to consider this subset as a main data set now, and there are 5 rows, out of which 2 yes and 3 no's. Using that, we have to calculate the overall entropy. And the information gain for income can be calculated from the values. So income is having 3 categories: high, medium, and low. So if the income is high, it is having 2 no's and 0 s. So the entropy will become 0, since all rows belongs to same class. And the income is low, it belongs to the same class S, so the entropy is again becomes 0. And for medium, I'm having 1 yes and 1 no, so we have to calculate the entropy as given below. So the information gain for income will become average overall entropy minus average entropy. So the value of the information gain for income is 0.57. Likewise, we have to calculate the information gain for student and credit rating. And if I'm choosing student, there are 2 categories, S and no. So for S, I'm having 2s and there are no no's, all belongs to same class, so entropy will become 0. And for no, all belongs to same class, 3 no's, so the entropy is again becomes 0. So the information gain for student can be calculated as 0.97, and for credit rating the information gain can be calculated as 0.02. Now comparing these three values, the highest information gain is information gain of student. So your decision node, next decision node will be student. So student will be your next decision node. So your decision node will be looking like yes, the entropies are calculated for fair and excellent, and the information gain for credit rating has been calculated. Now the highest information gain is for student. So student will be the next decision node. So your decision tree will be look like this. Yes. So your left side portion is not now solved. So student is having two categories, S and no. For if the student is S, it belongs to the class S, and if for the student is no, it belongs to the class no from the table. Here you can see for student is S, it belongs to S, and student is no belongs to no. So your decision tree will be looking like this. If student is S, it belongs to class S, and student is no, it belongs to class no. Now you have to solve the right side subset of your decision tree. So let us consider the right side subset, and taken as a given subset, we have to calculate the information gain. For this, the overall entropy can be calculated for this 5 rows. So out of 5, there are 3 S and 2 no's. So using that value, you have to calculate the overall entropy for this subset, and the attributes are income, student, and credit rating. So for income, there are two categories, low and medium. For low, I'm having 1 S and 1 no, and for medium, I'm having 2 S and 1 no. So the value will become like this, and your entropy will be, the value of the entropy will be remain the same, but while substituting the formula, we have to write 2 by 3 log 2 by 3 plus minus of 2 by 3 log 2 by 3 plus 1 by 3 log 1 by 3, log base 2 1 by 3. So the value remains the same. So while substituting the values, the information gain of income become 0.02. Likewise, you have to calculate the information gain for student and credit rating. So for student, there are two categories. So S and no. So if I'm taking S, it belongs to 2S, the class belongs to 2S and 1 no. If I'm taking no, there is 1 S and 1 no. So calculate the entropy based on the values and the information gain based on the average entropy. So comparing these three values, the information gain for credit rating is high. So credit rating is the decision node, we chosen as the decision node for the right side of the decision tree. Then it is having two values, fair and excellent. So if you are choosing fair, then all fair belongs to class S and all excellent belongs to class no. So yeah, if it is fair, if your credit rating is fair, it belongs to S, and if it is credit rating is excellent, it belongs to no. So this is the final decision node constructed for the given data set. So let me show you the given data set in the first slide of this video. So here this is your given data set, and now we have constructed the decision tree for this data set. So this is the decision tree we have constructed for this data set. Thank you for watching the video.